Analyze the visual information in the potential energy diagram. Reaction profile. Both reaction profiles start at the same initial potential energy level, representing the reactant, XY2, and end at the same final potential energy level, representing the products, X plus Y2. The enthalpy of reaction, delta H, which is the difference in energy between products and reactants, is identical for both paths. Both depict an endothermic reaction with delta H equals plus 50 kilojoules per mole of reaction. The only difference between the two curves is the height of the energy barrier from the reactants to the peak of the curve, which represents the activation energy, EA. Path 1 has a higher activation energy barrier of 150 kilojoules per mole of reaction. Path 2 has a lower activation energy barrier of 100 kilojoules per mole of reaction. Recall the chemical function of a catalyst. A catalyst is a substance that increases the rate of a chemical reaction without being consumed in the process. It achieves this by providing an alternative reaction pathway mechanism that has a lower activation energy than the uncatalyzed pathway. By lowering the activation energy barrier, a larger fraction of colliding reactant molecules possess the necessary minimum energy to react at a given temperature, which increases the reaction rate. Crucially, a catalyst does not alter the thermodynamic energies of the reactants or products, meaning the net reaction enthalpy, delta H, is unchanged. Connect the catalyst's behavior to the paths. Since path 2 shows a lowered activation energy peak compared to path 1 while maintaining the exact same reactant and product energy levels, path 2 represents the catalyzed reaction pathway and path 1 represents the uncatalyzed reaction pathway. Thus, the difference between the two paths is accounted for by the presence of a catalyst in path 2, which corresponds to option D. The correct answer is option D, the presence of a catalyst in path 2.